Now see here, next topic is here electrostatics of conductor. First one is inside a conductor electric field is 0. So actually we are going to discuss about the properties of the conductor in the electric field. So first one is inside a conductor electric field is 0 in a static situation. Suppose you have got any conductor and that is in a static situation, there is no current inside or outside it, that means electric field inside it, that is 0. You can also understand by this way. Suppose you have got, this is here the positive plate and now there is negative plate. So direction of electric field these two plate is E naught, this is inside it, that is vacuum. Now there is conductor. If you are placing a conductor here, conductor has got the charges which can move, free to move. Because of this electric field is this side, electron will move opposite to the electric field. So all the electrons of this conductor or the electrons of this conductor will align to this side and positive charge will move to the direction of electric field. So positive charges will come to this side. This will continue till the electric field inside it, that is EP, that will become equal to E naught. As soon as electric field inside the conductor EP becomes equal to E naught, then the movement of the charges to the this side or that side, that will stop, that is the condition of equilibrium. So now we know E naught is equal to EP. So net electric field inside the conductor, that is inside the slab, is E is equal to E naught minus EP. Now E naught and EP are equal, therefore inside the conductor electric field is 0. So that is the first property, inside a conductor electric field is 0. Now see a second property, at the surface of a charged conductor electrostatic field must be normal to the surface at every point. Suppose this type of the conductor I have taken, which is given charge plus Q. So at any point actually electric field is normal to the surface. If the charge density, that is a sigma, is greater than 0. If sigma is less than 0, then electric field is normal, but the direction is, that is radially inward. So actually what happens, if you keep the charges over here at any charge on this surface, then this charge does not move tangentially. It means there is no tangential component of the electric field, or you can say no charges are moving here along the tangent. It means electric field at the surface is equal to, that is perpendicular to the surface, or that is normal to the surface. Now see the third property, the interior of a conductor can have no excess charge in a static situation. Suppose you have got conductor like this, which has got charge plus. So as the charge is given to this conductor, charge resides on the outer surface and comes to the surface. Now suppose if you take any volume over here inside it and draw the surface, that is called Gaussian surface. By taking this surface here, if you apply Gauss theorem, inside the conductor electric field is 0. So you know it, when the electric field is 0 inside the conductor, it means flux is equal to 0. So flux is equal to, that is Q net upon epsilon naught. So when the flux is 0 inside this, it means there is no net charge inside the conductor. So we can say that the interior of a conductor can have no excess charge in the static situation inside the conductor here. Now see here, fourth one, electrostatic potential is constant throughout the volume of the conductor and has the same value as on its surface. Suppose you have got a conductor like this, where the charge is given here plus, and we know its charge resides on the surface, inside this electric field is 0. So we know it, this relation E is equal to minus dV upon dr. So inside the conductor when electric field is 0, so that is here dV upon dr equal to 0, that means V is constant. If it has got the radius r, so potential on the surface V is equal to Q by 4 pi epsilon naught r, and the same potential is on the surface and inside it wherever the electric field is 0. So, inside this conductor electric potential remains constant throughout the volume. Now, see here the fifth property, electric field at the surface of charged conductor is E is equal to sigma upon epsilon naught n cap. Sigma is here surface charge density, Now, n cap is here, that is the direction outward, electric field is in the direction of the n cap here. So, now we have taken a conductor here where its surface charge density is sigma. To calculate electric field, just I have considered here the cylinder which is passing through the conductor. So, now what happened here? The one part of the cylinder is outside the conductor and one part is inside. The part which is inside, their electric field is 0. So, there is no flux, but the part which is outside here, the electric field is E. Suppose this area is here ds. So, we can write E ds is equal to q by epsilon naught. Q is the charge enclosed by this surface which is on the surface of the conductor in this area. So, we can also write E ds is equal to sigma can be written in terms of the charge density, that is sigma into ds divided by epsilon naught. This and this will get cancelled. So, we will be getting E is equal to sigma upon epsilon naught. This electric field is outside. So, we can put here the vector here and n cap. N cap is the showing direction here outward. So, the electric field just outside the cylinder, outside the surface of the conductor is equal to sigma upon epsilon naught. So, now see here electrostatic shielding. What do you mean by actually electrostatic shielding? See here, we know it inside a conductor electric field is 0. It means inside conductor we do not get any electric field. That means E is equal to 0 because the charge resides on the outer surface and there is no motion of the charges, that shows there is absence of electric field. So, here this concept where the electrostatic field is 0, that is actually if the electric field is 0, we can shield that surface from the electric field. So, electrostatic shielding, it is the phenomenon of protecting a certain region of space from external electric field. Suppose you have taken a conductor where we have got the charges like plus here sigma greater than 0, electric field is outward. Similarly, here the plus electric field is outward. Here is negative, electric field is perpendicular to the surface and inward direction. Similarly, here. Now, there is a cavity which has no charge, and whatever the shape and size of the cavity, it does not make any difference. So, if there is a cavity with no charge, then inside this cavity the electric field will be here 0. See, if anything is placed over here, that can be protected from the external electric field. And also suppose if you are inside the car and during the lightning and the lightning is coming here, so you are safe inside the car because inside the car electric field is 0. So, you are not affected by this. So, sometimes big electrical devices even like electric generator are also placed in the cages made of the conductor, so that they can be protected from the external electric field.